All right, we're going to look at applications of log functions and how to answer questions related to it. So let's have a look at the first question that's related to health. I think it's actually quite timely in the midst of all the COVID-19. So in a school with 1,500 students, one student returned from vacation with a contagious flu virus. The spread is actually given by a function, and you can see that it's down here, right? So this is the function here. So you have to take note of some key points. So in this case here, some of the key points would be that y is actually the number of students, and we have t days. All right. So school will be cancelled if 40% or more of the students are ill. So how do we actually go about with the questions? Let's have a look at the first part. Now the first one is actually quite simple. How many students will be infected after 6 days? So in this case here, right, you have t equals to 6. So you have to understand that there's actually 6 days. So you just have to replace it into the equation. Y equals to 1500 over 1 plus 1499 e to the power negative 0.85, t being 6. All right, so this is where you replace it. So you just have to use your calculator and calculate it out. And correct to 3SF will be 148. So in other words, approximately 148 students will be infected after 6 days. So this is for part 1. Now part 2 will be a bit more complex. They said that 40% or more of the students, if they are ill, then classes will be cancelled. So after how many days will the school cancel classes? So which means that we have to find out, right, what is this 40%? So you have to understand that the school has 1,500 students. So if you actually multiply by 40%, that will give us 600 students. All right. So basically, we want to find out, right, how many days, when will it be that we will have 600 or more of them be infected? All right. So which means that we have 1500 over 1 plus 1499 e to the power negative 0.85 t must be greater or equals to 600, because minimally 600 students. Of course, more than that, it will mean that it will be closed. All right. So what we can do now is that we can actually sort of like exchange places. All right. So in this case here, I'm going to bring, okay, let me just highlight this. I'm going to cross multiply. So in a way, I'm like multiplying both sides by this. All right. And then, okay, maybe I just do it step by step. So I will have 1500 greater equals to 600, 1 plus 1499 e to the power negative 0.85 t first. All right. Then let me get rid of this one here by bringing it over the other side or dividing both sides by it. So I will just straight away write down that we have 1500 divided by 600. Okay, so we have 1 plus 1499 e to the power negative 0.85 t. All right. So then from here, what we are going to do is that we are going to get rid of this one here. So this one here, if you actually reduce, you just get 15 over 6. All right. So what we're going to do is that now we are actually going to get rid of the one here. So let me just write this on the left hand side, 1499 e to the power negative 0.85 t. So this part is actually the smaller than, right? So we're going to just write smaller than. So this would be 15 over 6 minus 1. All right. Now, once that is done, when you actually divide it, subtract it out, you should be able to get it as 1499 e to the power negative 0.85 t less than or equals to 1.5. Then we actually want to solve for t here. All right, this is the t. So we do not want to have any numbers in front. So what we're going to do is that we're going to divide both sides by 8. So e to the power negative 0.85 t is less than or equals to 1.5 divided by 1499. All right. Now, this one, the t, right? Again, let me just change color. So this t here is sort of like hanging in the air. So we need to bring it down. The only way you can bring it down, right, is by putting a lock. Otherwise, it cannot be brought down because you need to apply the power rule. So just imagine that this one here is like a rabbit hanging in the air, right? You need a lock for the rabbit to jump down, okay? So because this one here is E, we are going to introduce ln. Okay, so remember, I'm going to just write down a note here. Ln is the same as log base e. Alright, so I'm going to put ln e on the left and ln on the right. Okay, so I am introducing ln on both sides. Now, what's next? So now, this one here can actually be brought down. So we have negative 0.85t. Now, do not forget, right? Ln e is actually the same as log e base e, because ln is actually log base e. Anything with the same base is actually 1. So this value here is actually just 1. So I don't have to bother to write, but I can just write it down this way. And this is where we will actually have ln 1.5 over 1499. I'm just going to write it as ln first, okay? Now, since we are trying to solve for t, so don't forget this is a negative number, all right? So let's change all to positive first. So this one here, okay, this is negative, right? So I'm going to change to positive. So I will have to change the sign here as well, all right? And of course, I will have to change here as well, okay? So far, so good. So now, since I want to solve for t, I will have to divide both sides by 0.85, okay? So this is what I'm going to have. T equals to negative ln 1.5 over 1499 whole thing divided by 0.85. Now, when you have done that, you will be able to get it roughly correct to 3SF as 8.13. Now, this is where the tricky part is. The question says that after how many days? So the common mistake that many students make is to actually round down, because if you look at this one here, right, this is actually a 1. So you have been well trained that it's not enough to round up. So you will always tend to round down to 8. But you have to think about it. If you round down to 8, right, and you actually put it back into this equation here, you would have actually gotten fewer than 600 students. So that's why it actually would be after 9 days. So the answer is actually 9 and not 8. So this is where you have to be very careful to round up or round down. Now let's look at ethology. So there are approximately 5 times as many long-tailed macaques as banded leaf monkeys in a nature reserve. The population of long-tailed macaques decreases at 5% per year, and that of banded monkeys, it actually increases at 10%. So you notice that now, right, there's actually a difference. One is actually more, one is actually less, okay? So as years go on, or as time goes on, for the macaques, right, it's going to be 95% because it decreases at 5%. So if you're going to look at this case, right, we have to think about it first. Now, they didn't tell us how many they were originally, okay? So they just told us that there are 5 times as many of these macaques as compared to banded leaf monkeys. So what we're going to write down here is that let banded leaf monkeys, okay, the numbers be anything. So let maybe just use k, because k is usually a constant we use, all right? So that would be the number of banded leaf monkeys initially, all right? So this is initial. So if that is the case, right, then the macaques will be 5 times as much initially. So there'll be 5k. So again, this is initial. So they ask you to create a population model for the long-tailed macaques. So you have to understand that as time goes on, you want to find out how many is there, how many will there be, all right? So let's just use m for macaques. So m, so the number of macaques will be, originally, right, macaques will be 5k. So this will be the original number. And since it decreases, okay, let me just highlight here. Since it decreases at 5% per year, so this would mean that I have only 95% as time goes on, all right? And this is t, so it's a function of time. So this will be the yearly, right? So they already mentioned per year, so which means that the following year only 95% of it, and the following year 95% of the previous year. All right, so that's why it's 95%. So this will be the model for the macaques. Now, what about for the long banded leaf monkeys? So we were going to just use L for banded leaf, so L for leaf. So original number is actually K. So this is the original population. And this one is a bit different because it increases by 10%. So that's how you have 1.1 T. Now, in case you're wondering how I actually get 0.95 and 1.1, it's very simple. 95%. Change to decimal. That's how you have. Okay, for this one here, 1.1 is because it's 110%. Okay, so that's how you get 1.1. So that's how you have it. So second question says that using the models, how many years must elapse before they are actually equal in numbers? All right, don't forget, one, there were more originally, but it decreases by year. The other one, smaller originally, but it increases by year. All right, so what we're going to do is that we are going to equate them. All right, so what we can do is that we have 5K, 0.95T. So this will be for the number of macaques. Sorry. Right? And this will be for the banded leaf. Sorry, let me just change the color again. Right, so this is banded leaf K, 1.1 T. So what we're going to do now is that we are supposed to find out the time, because they say that how many years must elapse. So the question is how many years must elapse. So we are trying to solve for T here. Now, if you look here, right, very carefully, you can actually see that I can actually divide both sides by K. So I divide out. All right. So from here, all I have is 5, 0.95T equals to 1.1 T. All right. So all the T terms I can bring to the same side. Okay. So this is where I will have. Okay. So maybe I just keep it to the left hand side. 0.95T and this one I'm going to combine 0.95T divided by 1.1T equals to, bring the 5 over, this is 1 over 5. Alright, you can do the other way, it doesn't matter. So since both of them have T, okay, actually I should have written it the same, never mind, it's okay. So this is 0.95 over 1.1 T. So it's as if I'm actually bringing out the power. Alright, this is from the law of indices. Okay, so this will be 1 over 5. Now, since you have to bring the T down, okay, so this is the T here, and you need to bring it down. So you have to introduce log. Now, you can use either LG or LN, it doesn't matter. So let's just use LN because previous one we also use 0.95 over 1.1 T equals to 1 over 5. Then this is where you notice that T can jump down. Alright, so this is where we'll have T ln 0.95 over 1.1 equals to, sorry, I forgot to write down here, ln 1 over 5. Okay, so you have to actually introduce log on both sides. So as I mentioned, you can also use log base 10. It is fine, no issue about it. Alright, so now that you want to solve for T, you are going to be able to just divide out both sides by this one here. So T equals to ln 1 over 5 divided by ln 0.95 over 1.1. And then you'll be able to get it approximately at 11. So in other words, you'll be 11 years before the population will be roughly the same.